Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 18, 2025, about 4 days ago. It introduces SGI-Bench, a scientist-aligned benchmark of over 1,000 expert-curated tasks, and it finds that even strong large language models only hit about 10 to 20% exact match on deep research questions. The paper is titled, Probing Scientific General Intelligence of LLMs with Scientist-Aligned Workflows. And, as we'll see later, the workflow style evaluation exposes some surprisingly stubborn gaps that matter for real scientific discovery. Also, the authors shared an official SGI-Bench GitHub repo. You will find the benchmark data and an agentic evaluation framework spanning deep research, idea generation, dry and wet experiments, and multimodal experimental reasoning. The repo also includes quick start scripts, per-task environments, scoring utilities, and a leaderboard plus SGI score aggregation. Figure 1 lays out what scientific general intelligence is supposed to mean in practice, which is an agent completing the whole scientific inquiry loop. The practical inquiry model is a 4-stage map of scientific thinking, so it forces evaluation beyond trivia-style knowledge. The left side emphasizes deliberation through scientific deep research, like literature inquiry, and meta-analysis. The bottom highlights conception as idea generation, while the right side splits into action for dry and wet experiments and perception for experimental reasoning. Figure 2 turns that inquiry loop into a concrete benchmark pipeline, so the evaluation tracks what scientists actually do. This figure shows the full workflow, from big, motivating questions through 4 task families. The top row highlights scientific deep research and idea generation, where multi-hop search and meta-analysis mean gathering evidence across sources and then combining results quantitatively. The middle row covers dry code-based experiments and wet lab-style protocols, and the bottom panel shows how experts and annotators construct and clean the dataset. Table 5 makes the main point concrete, because it summarizes how current models perform across the whole scientific workflow, not just one skill. This table shows the full grid of models and task family scores, with the overall SGI score shaded on the right. The deep research column stays low even for the best systems, while idea generation often looks stronger on average. The best overall entry lands in the low 30s, so the gap to reliable end-to-end science remains large, even with top closed source models. Figure 26 shows how the model can get better at idea generation at test time, even without labeled answers. Test time reinforcement learning means the model updates itself during inference using a rule-based reward instead of ground truth. The left side starts with a query that the policy model answers with multiple candidate ideas, while a web search collects related works. The middle reward box adds a format check plus an idea dissimilarity score, and the right side turns those rewards into a group update step. Alright, 2 takeaways stand out. First, the benchmark shows that today's large language models have pieces of the scientific workflow, but they struggle to carry correct, end-to-end conclusions, especially for deep research and wet lab-style planning. Second, test time reinforcement learning hints that inference time optimization can boost novelty without labels, which is promising for discovery. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.